TV viewers in front of you with listeners. Hello everyone, I am a teacher Fu Helling. Very welcome to watch again Surprised Universe. Today I want to say on the topic of the sun. The sun, whether opened his eyes closed, are closely related. We all know. The sun gives us light with heat. I actually have read. The sun is always changing. Dynamic been changed. Distorted magnetic field system. Because it distorts the magnetic field. So it's like a big generator of the same. Have a great big. We maniaxiang energy. That sun looks as if there is round. Nothing changes, in reality, far from our imagination. It is just a group of light-emitting plasma. It has a sun flame. Their filaments have prominent sunspots. Their coronal jet. These things make it a Mother Earth energy. We are simply see this photo. The sun is a star. It is composed of hydrogen helium with other heavy elements. A composition of a substance incandescent. A mass. So inside the solar system, number 2 is called Jupiter. The Jupiter. In the year when the solar system formed. The sun is with brothers. Then each other to grab first place. What do first? Is the ability to have their own nuclear fusion. To be able to achieve it. Fusion of so-called critical mass. Critical mass, but Jupiter sent so little. The result was snatched sun. So now the sun is a star. Jupiter is a gas planet. But it goes round the sun. As is King Loser for Co. This map will tell you. The world you want to see the sun. You have to use binoculars, but in reality. The sun's sunspots last time I talked about in China. Conduit time in China. Has seen a sunspot. It has to go to the west with the telescope. He was able to see sunspots. That this is the history of the West. We can see 1609 Galileo. He changed the amount of a Dutch telescope. To increase its multiples. So 1610. To use the telescope after he improved. Observe some. Very strange phenomenon of the sun. Then in 1159 a man discovered. The sun's surface. 1859. And this sunspot. Phenomenon caused by the Carrington 1959. Then do we take a look at this. Before this I want to trace the Galileo. The word on the left. BC 450 years time. Humans have been the center of the sun for the first. Then in 1453, Copernicus proposed sorry. The sun is the center of our entire solar system. Galileo is his supporters. Of course, the two men are not very good results. To the 1700 to 1800 time. Scientists have studied the sun will emit a spectrum. The spectrum there are sunspots. And the inside track. So began at this time. Humans began to notice, the sun affects the earth. There are a group of black stuff. So this is called 1859. That followed it in 1868. There is an American scientist. This is a very great man, called Higher. The Higher did what he does. He studied sunspots. Will there be a relationship with the magnetic field? This is his first put forward. That this relationship because he is. Of course, he could see sunspots. He must have eyes not so good. He must have some equipment. He is the telescope. So he create first-class telescope. He is an expert. You just ask this Hale. HALE famous figures. Then 1920-1930. We now know. The sun itself using 4 hydrogen. A heavy metal fused into helium. Nuclear fusion generation effect. Producing energy. Then that is what we see. Why do I pull this page? We see. The top is called Skylab. We notice that you use Google to search. Called Spacelab not see. You use Skylab SKYLAB. You can see the sky experiment. Why do I talk about it? It is a number from June 14, 1973, to number 11 July 1979. As we all know, 1969, United States landed on the moon, followed by the Apollo 14. 15, 16, 17, 1972. After it stopped, the Saturn V, still there may also act. So the United States NASA, on the use of the Saturn V, hope to develop the most original space station. What is its purpose? Observe the sun. They know. If you want to get out of Earth, you must understand that the sun sometimes you come over here. Weird things. It is very dangerous to your astronaut. You do not get this Earth. The Skylab that there are 77 tons. Cycle lap course around the Earth 93.4 minutes. That height about 430 kilometers. The ratio of the ISS. Slightly higher a little bit, then the inclination is 50 degrees. So stay note 2,249 days in space. The inside of it were sent 3 batches of astronaut. Once 3 people 3 times 3 is 9. SL2, SL3, SL4 with. So what task it performs is to observe the sun. The results of it cannot be said to be broken feather and go. It did last experiment. It originally expected will continue to extend to 1983. As we all know, U.S. Space Shuttle, 1981 maiden voyage began. It hopes to continue in conjunction with the Space Shuttle. I'm sorry, but not from day one is willing to. The most important reason is the United States in 1973 to 1979 between this time there. For not much understanding of the sun. So for the sun, it will generate additional heat caused by satellite and sudden changes in the spacecraft's orbit, far beyond what they think is expected. So Skylab this track can only be changed, very dangerous, slowly fall to Earth will go up, so ahead of Henka. This is the first U.S. spacecraft plan. I wrote here, then immediately see behind. Soviet International Space Station, Chinese horoscope and a horoscope too, there to see this tonnage. In 1973, when U.S. Saturn V can also place 77 tons of spacecraft up. The first spacecraft, but then what? Soviet Mir spacecraft in 1986, nearly than the United States. Probably around late June, nearly 7 years. It has come to 129 tons of it Proton rocket, then the Proton rocket. The International Space Station is the first major ship, that is Zarya. It is Russia's first own up 19 tons, but the ISS total weight is 420 tons. It is up batches, but the U.S. Saturn V 77T is a go. Mir Space Station 129T. Also the most part up. The entire combined 129 tons. Then a Chinese horoscope Temple 2, probably currently about 8.6 tons. Well, we now look at the next. This very brief. This is inside the main emphasis is called sunspots. The sun's sunspot is a very critical. We see 1610 on the Galileo studied. We are at a very early conduit. Thousands of years ago to study the sunspot. Sunspots which is dispersed in the photosphere. Photosphere magnetic layer of one of the convection cell. A body of a group. Every time it appears, you see this is the lowest its sunspots. This amplification, after the United States, experimental observatory power of sunspots shine. Then on the right is the effect of sunspots occur. The black relatively speaking. Temperature is relatively low. It is why the temperature is relatively low, because it has a strong magnetic field in their role. All it can produce. The so-called called a cool dark area, then like the sun. Because it is this energy, have absorbed a little bit. Therefore, less energy is emitted to. This is one of our sun. Be very simple to understand. The sun can be divided into its internal. It can be divided into its atmosphere surface. It can be divided into the external and is corona. First we look at the top left. We see the middle of the solar interior better. The middle is inside the sun. That day is the core of nuclear. It produces nuclear fusion, extremely high temperatures. It followed that the upper left. Sun convection inside layer. Then there is the radiation layer. Then the radiation layer. Its energy is very slow. It should energy from the center. Note that radiate outward to the surface. How many years to external radiation on the surface? A 110 million 17 years. It radiates to the surface. 17. There is an intermediate upper troposphere. It is the energy of the entire troposphere. There is a ring of convection circle, moving flow of cold air which is also, then the convection movement of the movable, produced a magnetic field, so the inside of the magnetic field lines, just a lot of the inside out. Then we look at the bottom left immediately. Bottom left is the atmosphere. The atmosphere is the coronal streamers, that it ran out outside. Corona called coronal. It is a plasma flowing outwardly. The magnetic field that the plasma is shaped conically. Then we call coronal streamers. Called a coronal stream. It can drill in space. How many millions of miles? We look to the right, on the right below. Sun's atmosphere is mainly chromosphere. Chromosphere. The chromosphere it. The above magnetic field substantially, one by one. Wait a minute, we can see this magnetic field, but it also has a one thing. One by one the things. There are a number of ionized particles in the above. The imaging ears as, like what we call ear wire prominence. After that forming the prominence. Slowly extending slowly enough energy, it forms a thermal crown is coronal. This energy is then again after the big coronal. After injection it will flare out. Produced coronal mass ejection CME. Then the CME a thing. It is nearly 2000 note. 2000. It coronal breakout, probably sometimes 5 minutes. Sometimes 10 minutes, sometimes 19 minutes, can play out so much energy. Then the top of the upper right is the solar corona, basically corona. It is free of some of the elements. US NASA. Using this telescope X-band. Carefully see the corona. And then found that in the whole of the solar corona. This change with sunspots are closely related. Okay, we probably look good. Then take a look at this picture that's prominence, a silky thing's not seen. Like a faucet as, the prominence it slowly. This is more powerful prominence, so clearly seen on the sun's surface. After playing out, it slowly becomes a coronal. Then this picture is that it is playing out in the future, the large amount of energy to break out from the sun. This is the solar wind. After that the solar wind break out. The sun emits its high-level atmosphere. The main content of this there is an electron with a proton, so these things, with temperature change with speed and do. Notes that it is not straight. It is not straight. It is a spiral vortex. A spiral. And wait a minute, I'll put last film. U.S. spacecraft Parker. It has been found to a phenomenon. Closer when the sun. It is the spiral tip. Will play out in a straight line directly, rather than the bending line. This is the latest discovery. This is December 2019. Parker saw the footage back. The fifth major discovery. Okay, now I want to introduce this. This is very important. A U.S. spacecraft, solar-powered spacecraft called. This is called Solar Dynamics Observatory. Study the solar atmosphere and the impact on the Earth's space. It was launched in 2010. The first 2 photos. This prominence is left. Ear of a king. Then after the formation of the solar prominences, become a coronal C-no. Then the middle of its field. Inside drastic changes. Very thin each of its magnetic field is. The scarlet letter which I have. This is a very interesting. United States is now being studied, from the sun to study. How to store magnetic energy. We are now talking about solar cells, right? Electric cars. Take up energy received by the receiver. How about receiving it? Lithium battery save up call ferroelectric. This is what the battery, now this latest magnetic energy storage technology. Now the United States is studying, but it did not disclose the results. Well, this photo. This is not to see. This photograph is left today. This is the last photo on the right. Because I just catch data, draw to control, from the information yesterday arrested. This is America SDO, a very important tool for observing the sun. This left, as already has 2 coronal hole. There are 2, we called coronal holes black. The magnetic field lines from the inside to break out, but not the right. So different, although 2 days. Different about 2 days, but this thing. It affects the results are not the same. This is a scene straight out of Grasp. These 2 pictures is to shine out of SDO. You said, Fu teacher. Why do you pay much attention to the sun? Notes that in fact the sun. It will not only bring us the light with heat. It was noted, we spend all day talking about renewable energy. If we use renewable energy is the use of the sun. The so-called wind power, solar power. Although these are intermittent energy, currently is not able to directly replace. Why the so-called direct energy? Because if it one day, you do not have the solar wind is not how to do it, but it can reserve at that place. At any time in the future, our technology development to a certain extent, Kenji Shenku, we all know that if we produce to generate electricity using renewable energy sources, if you use a kilowatt of renewable energy, you can reduce each unit of electricity 0.67. So the whole of the Earth. We always want to address so-called 350 ppm, the carbon dioxide to be reduced to this stage. with the development of renewable energy sources, are closely related. Well, this is something. Okay, let's look at this photo. This is what we see: light ball. Note sun. We speak from within the core. Then extraneous radiation is convection. And then on top of that surface, we only see the surface of the photosphere, the ball of light surface. Notice what to see one by one. Did you notice things one by one? This is called the small particles. The small particles does not look smooth, but also looks like what? One by one the things. This is called convection cells carry. The top of it, direct heating from the depths of the sun. Note that this incredible energy, each one the same as the bubble. A 20 per Taiwan, so much. A 20 per Taiwan. This was in 2004, National Geographic speak. This is not what I say. This is written in a magazine. Then the ball of light. Each one ball of light about 1,000 kilometers across. 1,000. So how much does a good thickness? Thickness of the light ball is probably about 100 kilometers. Our sun. We look at the past of visible light. We only see the light ball. We do not see the chromosphere. We only total eclipse, or an intermediate time is blocked. We can see what color ball. Therefore, only to see the ball of light. This tells us that the sun is a ball of gas, unlike the Earth as it rotates. How many laps revolutions per minute? 24. Sorry, it's uneven. Sometimes fast, sometimes slow. We look at the right side of this chart. That red with yellow is relatively fast. The rotating faster than the blue place on the slower rotation. Because it is a gas. Well, what the sun is a big solar dynamo, is a big generator. It is due to the distortion magnetic field cutting. So this so-called power generated electricity. Well, this one does. I will wait to put the first film. This is NASA SDO in 2010. The Solar Dynamics Observatory. It made a memorial video. The 2010 to 2015. When the shrink film to tell you. The multiband telescope. We can say that the telescope observatory can see what? This is it. Different light absorption characteristics different from the, well, we now put about this film. From this film, we can see different sun. Have you noticed a different sun? The shiny place. It is playing out of flares. Flares break out. Then next, notice next to the profile. This is called the outside contour of the so-called. You can see the chromosphere. Chromosphere is generally invisible to see the edge. It then different light. You do not see our middle flare. Then that is occasionally breakout flare. Flares. Then coronal mass ejection. CME is so played out. It's this thing with a different color. Why? Basically this. We see that ball of light the sun's surface. About 4,500. This is a flat view it. You can see the different colors. Then you can see its furry collage. Magnetic field. Mini plus changes its magnetic field. Blue. This photo is more interesting. Blue with purple. It is an A-ray X-ray telescope according to. See its magnetic field changes. Well, horizontal stripes do not see. There's a stripe, horizontal stripe. It represents the change in the magnetic field warm inside. The so-called coronal hole. This is its sunspots. And the above sunspots very quiet. No. A bunch of sunspots appear a group of sunspots. Then turn sunspots. You use this ultraviolet telescope. Or a high X-ray spectrum of the telescope. Saw a black hole. Coronal hole, that is the coronal holes. This one is to see its magnetic field, where large groups is the change of the magnetic field. Where is the change in the magnetic field of sunspots area? Then look at. This place has a lot of black stripes. Coronal hole is not a hole. It may be a stripe you see. Just see the red. Then came out of. Flare is that it flares out to play. Flares enough energy to break out of it. Is to become a coronal prominence. CME outwardly injection into coronal. Then spray to earth. This is probably a movie will tell you. In this video you can see. And it is very strange coronal hole. Sometimes in extreme poles appear. Sometimes occurs is not necessarily in the middle, so black area. The more you see the flash of the place. Represents the sun, the greater instability. It will heal a lot of energy projectile out. The formation of the solar wind hit Earth, caused by many things. But the solar wind hit Earth up. Basically. But it has a relationship to electrical. Is not necessarily so. We know that this ball of light. We saw a ball of light. Basically degree 5,700. Only 5,700 degree temperature. But outside the chromosphere. It becomes a temperature of 60,000 degrees Celsius. Outside the chromosphere into the atmosphere this time. Sorry, 1 million degrees temperature. You see this a lot. Each change in color represents a different temperature. To the atmosphere when the temperature of 1 million degrees. But. Coronal mass ejection. Corona went out. 100,200, that at outside temperatures, with the top temperature of about 300-fold difference. In one instance, I was warming himself right now. Basically, how about the more distant from the fire? It should be colder fishes. I'm sorry, at more heat. So this is why the inside. United States is now a fight. Parker satellites. Spacecraft to understand this reality. Well, we have just talked about the sun. We are talking about things around the sun. This one is called the heliosphere. See note. This Voyager 1, Voyager 2. There are only 2 Voyager spacecraft. We currently above Earth. 2 man-made object to leave the solar system. Voyager 1 is now Voyager 2. Then notice. The top layer is the end of day. That is, it has a tail called the day layer tail. I do not explain all. Look. The second of it. It is called bow shock. Is the bow shock wave surface. On the outermost bow shock wave, that layer of surface, this is we humans have been imagining, but this time Parker satellites. After basically up. I'm sorry it did not see this one. So our human past. Sun has been doing model assumptions. Is there a little bit to fix? Then again there is a terminal. Termination shock. This one has a terminal shock wave. Then once. How do we from this? Change in the number of high-energy particles. We can know. It has not left the ball. What is this ball? All of the solar system are in the interior, outside the high-energy particles. Everything in this heliosphere top. And inside this sheath this day almost. The energy began to roll. This magnetic field inside our solar system. With the solar wind to the maximum boundary. As well as outside of high-energy particles do over there. To do this balance. If you cannot balance. All particles outside is blocked in this one. So this one-day sheath. It can be said is how to protect against solar system. This high-energy particles from outside. This is very, very energetic particles hit badly. So why scientists are to study? Because humans must be out of the Earth. Be sure to get out of the solar system. If you want to get out of the solar system, you have to understand this one. Well, I talked about this. Then the inside. The United States also has launched a satellite. This is called the Interstellar Boundary Explorer. Short called IBEX. The first study of the heliosphere. That is, on the surface of this one-day sheath. What are some things? The results found a very, note that this does not see the red, blue word. Notice this red dot above. It found that a very narrow circle called the energetic neutral atoms jet. Never found. But did not find the bow shock wave. No bow shock wave. I am using a spherical situation. Note that this red place. This place is a red appears. This is the so-called local high-energy neutral particle distribution. So say representatives from the Japanese point of view sheath above, surface of the sun and the solar wind reach. The outermost boundary of the above, there are many things we do not know, now we find. The red stuff, more important than other things. Okay. Then this means that the inside of our can see a great amount of change in the sun. A cycle because the sun every 11 years, called the cycle of the sun, cycle solar cycle. When the solar cycle one small minimum. See no notice. It is outside the high energy particles play up, Ben is not very high yellow. But once the sun, maximum time is the. It is simply not, it is indicated says, sun with maximum minimum. It can be said decision. What's out there to hit the solar system? And then come up to hit Earth. How many chances? So this equipment see clearly. This represents a change in the cycle of the sun. Are closely related to the entire solar system, can protect the entire solar system. Well, this is the sunspot active period. The solar maximum and minimum. 23-year period. Then the leftmost 1986. At this time the sun is very quiet, there is no sunspots. So there is no solar storms. But in this cycle inside, this is the first 23 cycle, then came 2000 to 2001. You see a joke, the entire solar flame, the coronal hole. That all appears black hole. So the cycle to the most dramatic moment. Below that there is a butterfly. This is the same look butterfly diagram, however, above A, our common science terms, use the above to see it. Okay, this is the same. Our scientists have been studying. This involves the inside. From this map you can see. This is what scientists, but not yet conclusive, 1610. 400. Make observations of sunspots. That's less time for its sunspots. In 1645 with the year 1715, this is a small ice age. Cold was bitter cold. Then the temperature of the northern hemisphere. Sudden decrease, alpine glaciers, has been extended to farmland ground. And on a beach, has been extended south from the Arctic Sea. So they say. Well, not this is a very significant. Of course, this was not enough to take a sample, but at least is a phenomenon. How many words that there is little evidence to say. Then this represents a say. Weather affected the sun. That is, space weather can affect the Earth's weather. This can be seen that this. The sun with the sun's minimum. In this view, the change on the right. This is Soho's this. A spacecraft observatory. 1995. Look left with these two figures AB. Then this figure does not see. This is a relatively stable, but it also has injection, coronal mass ejection. Sorry to exit the flare. Sun flare sun yin. But B is not the same as seeing no. It is not only the solar corona and there are eruptions, where a group out above. This is the maximum of the sun. The left is the minimum value of the sun. In 1995 this. 23 cycle. To see from the inside. The maximum value with the minimum, changes lively sun. Then you look at this chart represents. Left coronal mass ejection. CME has hit out. Right side of the black hole on the right there are a lot of holes. See right there is a lot of holes, forming over there. So this is a NASA this. Dynamic Space Telescope. A full disk multi-wavelength. Number 30 March 2010. Photographed sun's ultraviolet. A photographed image with ultraviolet light. There are red zone, blue zone with green area. Inside this notice, colder red zone. Temperature is only 107,540 degrees Fahrenheit. That blue with green area to pay attention. Blue with green zone temperature will be high, at least it probably more than twice as high. So tell us this picture. From this ultraviolet. Different color bands view. Color can know the level of its temperature. This is to see that it flares. It does not see the two flares, do not see the relationship between the two groups, is the flares. It is a breakout of change. White is the point. This is also the flares. You can see that this is very minor. This is the magnetic field, one by one line. A magnetic field is formed one line. A magnetic field is formed one line. Then from the inside, can be learned from the degree of density of the magnetic field. The coronal mass ejection. Playing out of time, a strong magnetic field to change its amount is estimated. This is its magnetic field. See no change in a root of the magnetic field. A root of the magnetic field changes. Well, this 1-2 maps. This is the right of our visible from inside. See the magnetic field. Visible see the magnetic field. That left this figure does. We saw in 2006 photographed, the strength of the magnetic field inside to see. The darker the area greater. Then the magnetic field strength greater. Then of course is sunspots, because the magnetic field of sunspots is change itself. That change in the magnetic field caused by its relatively low temperature, therefore the formation of black. But the intensity of the magnetic field you cannot see. That the right of this figure, you can see the intensity of its magnetic field. This is to say that, coronal mass ejection. Coronal jet substance. Have you noticed? This is the sun you see. The coronal jets matter how strong. The sun is so big, it's about the same amount of sun with large. This is two different photos. About two shot past from different perspectives. You can see it erupted. You see how much of that amount cover the entire. Like the entire grand sun. Joke. How the sun and the earth are right now. So if you really hit the earth above. Extremely. But we also need to be assured that is. Once we are facing the sun. If you really fight over. It depends on its poles. Your pole is not like me. Your magnetism like me. A little less sorry brothers damage. However, if the magnetic contrast sorry. A positive one negative, then all bets are closed. It would cause great harm. This is a good. This is the right coronal holes. A black piece of, on the left is the same when a photo. In the case of coronal holes, after playing out, it's coronal mass ejection. Jet flow jetted substance, probably just below the 180 degree position. You can see a large white stuff. So this is our atmosphere. We are very fortunate, the sun because of Japanese sheath. Outside the protection of the so-called energetic particles outside the solar system, it is no way to enter the solar system. Day sheath of the solar system, heliosphere protects our entire solar system. The same atmosphere has several layers of the atmosphere. Troposphere, stratosphere, thermal layer with the intermediate layer. Nearly probably about 1,000 kilometers. Of course, there is a middle ozone layer, the atmosphere which protects us. Sunlight bad things. All 4 layers are filtered out. Then of course there is a part of the ultraviolet. What are filtered out of the ozone layer. But our ozone layer will change, like breathing suddenly big and small. Once noted that the ozone layer is empty. Seeped up from the ultraviolet to the Earth's ozone layer. How to get skin cancer and why? Basically because of the ozone layer. It can be blocked. 106. Once there is no barrier to the negative 10 to the power of 6, this wavelength, you ultraviolet rays directly hit up. Just sorry. Human skin is a negative number 10 to the power of 6. Just open the door just right. So it is vulnerable to cause skin cancer. This photo is the sun and Earth. I just talked about the sun, right? And already talked about around the sun. Good sun itself impact on the Earth. You see on the right is the Earth's magnetic field. Once our now is the coronal mass ejection has hit out. Then this fight is on the right. And opposite magnetic overall receiver. This fight over the whole fight over. And it will soon begin. Do not immediately see, as if a stove. Burn a stove top. Earth's magnetic field began to produce a protective effect. But look. You do not like me with magnetic. Like me. Sorry, no, less damage. Sorry, not the same as playing up. From the Earth's magnetic field. Tail sheath on the most collage come. Next we look good. It did not stop to see part. No part of the block. Came in from the point of a red. Came to how to produce. Middle Earth that blue piece. On the so-called aurora. But I would suggest, aurora is also a high energy particles. Of course, some people like to see the aurora. When you see it, it has come to notice your body you want. This high energy particles on the human body itself. Some people also a good physique. Some sensitive constitution. For people who are sensitive constitution, there will be influenced by a number of. To tell you that this photo looks like the impact on the Earth. Only affect the electronic systems on the aircraft. Impact of GPS satellites. The impact of communications satellites. And the impact of the plant floor. We look. This is nice northern lights. I just say why. The magnetic field lines into the upper atmosphere and generate geomagnetic storms. Cause everyone's sightseeing. Dogfight money to spend 15,200,000. See this thing. But it has the disadvantage of it. Let me give you a very clear example. It was in March 1989. Coronal mass ejection. The corona jet. Have a great Earth magnetic storms. The magnetic storm. Unfortunately, it is in Quebec, Canada. Notice that I left this picture. Quebec is in my. The position of the nail thumbtack. You can see the right picture is. This is a satellite photo taken that day. All are dark. That line did not see all. I have a red line pull up. That line almost all dark. What people did not. Here is someone around like right. Not hit. The above is a hit right. The entire $2 billion power plant is gone. 20. Power for 12 hours and there are a good 500 million people affected. The thing that I'm speaking now This is the first 21 cycle I just talked about, the impact of solar storms on Earth. Right. Then produce electronic systems. If there is no relationship between us, but I just talked about the climate impact. I would let everyone see a thing. We look at this as the first 21 cycle. That is, 1976 to 1986. It was noted that in 1976, in the solar cycle minimum of 21, we have to note that 1976, Tanshan earthquake in 1976 July 28th, is in its minimum period. Of course, this must be found empirical. But we can safely assume that in fact, we carefully verify. This is the first case. This is the second case cycle 24, 2008-2019. Notes that in 2002 took place about 2002. This decline faster in the end is not in the end. SARS at this point decline. Then we look at the 24th cycle. 24 cycle. The bottom of the cycle right. 24 cycle. The left is 24 cycle of head. The right is the 24 cycle bottom. 2008. Wenchuan earthquake. 2008-512. The earthquake did not see. Is not seen in the minimum lowest point. What happens now that we Wuhan pneumonia did not see the two extreme points. So I just say a few case. I have just introduced the sun. I have just introduced the sun surrounding environment. I also just introduced Earth surrounding environment. Then the sun, there are bad things right. Then cause a lot of damage to electrical appliances, damage to the climate. Now these phenomena on Earth. If the probability is concerned, not surprisingly may be small, but a minute, then said evidence. I now give out these few examples, but in fact, there are many cases. We can all see. These things are said on behalf of the sun, minimum maximum with time. It is not something that discharge. These things some activity on the Earth. Even the atmosphere influential. Even affect humans do not know. However, according to several of our case, we can see some things. Then the inside. We can see that sunspot cycle 24 seems to be getting smaller, but it produces disaster. Does not seem to become smaller. Does not seem to become smaller. 22, 23, 24. So from the inside, we can see some things. These things cannot be explained by science. So, now U.S. scientists, to use science to explain. This figure represents the United States, that scientific progress. Note that this is a resolution. U.S. spacecraft. This is the highest resolution far right. You see clearly seen. Changes in the magnetic field lines. The two then left to see is not clear. Technology represents a well-developed layer by layer. We through this high-tech. See the sun more and more information. More and more information. Here again, I want to say a very memorable professor. Well, I put this page. This is my personal web page at school. www.fu.idv.tw. That was my graduate student I mainly look at this. I will miss a person. This is the University of Alabama. Space Plasma Space, and Director of the Research Center of the Sun, Professor Wu Chan. So this Colorado Air and Spaceport Seniors. He graduated from the Department of Aeronautics earlier than I was relatively late graduation, but he was very good to me. Then from 2000 until 2017. He often came to our school. The sun will speak with our understanding of the sun. I also have a few graduate students, because when I came back from the United States, my doctoral thesis is part of a satellite. I bring the sun added to the list. Do something to students. Students go published. Then the Wu guidance was give us a very deep guide. So this is my photo windmill. This is his own. Then unfortunately, his May 20th, 2017 death. 80. Finally, lying dead on the table to work. I miss him so much. In particular here to talk about. He is not only the United States and Alabama. Everybody knows, Space Department of the University of Alabama is very famous. He is the director of the Center for Qigong, director of the Center for. He not only to study the sun. And the sun has done a very good application. Have a close relationship with NASA. Then we know that the University of Alabama. Redstone Arsenal is the seat of the United States. Redstone Arsenal is the birthplace of the U.S. missile V2. It is indicated that the United States V2 in that place. With this Alabama has a close relationship. Get a lot of valuable information from his side. So here. In particular he talked about the sun. Professor Wu particularly want to address this. We gained a lot of. Back to the topic of time. Because of the time I'm going to put. Talk about a thing. Do this thing. 201896. New Mexico Solar Observatory suddenly stopped. And then reopened in September 6th. They do not know what's strange. Where does this place? This place does. The place is red. Position of the Sun Observatory. Red notice in the following places. Above it on the right in this loose wire. Loose wire above is Alamosi. U.S. Nuclear Center. The left is its air base. This one is a very important American research center for high-energy weapons. Then it has a high-energy weapons. Sun Observatory. In this place, and in 2019, a very strange thing happened. Then later news to nothing. 201896. I just tell you that there is such a thing. So some people say some say. At that time, when open, was photographed a movie. 20189111. Indiana photographed a movie. In the Antarctic below. Below the south there is a black spot. What is not unknown object. I was just raised to be a reference. Finally, I want to say A. 2020129. That is the end of last month. At the end of last month, Parker America's most important solar research. It examines why is the surface of the sun. Why particularly high temperatures inside the sun. At only 5,000 degrees below sunspot region. Approximately 5 degrees to more than 1,000 times above 300, 200. Why is the hottest place on the surface, rather than on the inside? So Parker telescope. Spacecraft to study this one. The most important news. So this is the case it shine. Photographed this movie. Well we now. Why should I notice this picture? Notice that the yellow dot is the sun. It cannot be too close to the sun, so they are like the long period elliptical orbit. After the last lap to avoid. After the last lap to avoid why? Since prevent valuable instrument on the spacecraft. Although visor but the fear of damage. We now put a good movie. As of the end of a theme. Now the spacecraft is with the hole. Do you see it? See no sun. There is a cover covering the Earth right. That's sunlight. This is Parker telescope. Continuous high-energy particle hit it. It still go ahead to move forward. Then the inside say this. The sun is not seen every 11. This is the change in its magnetic field. Then you can see it. Whole coronal mass ejection. Did not see the fight out. Then the left is the hot sun. It is flared flares. Do you see it? Just a black thing. CME is that it played in the past. Then what Parker is to steady up close view. Parker. Close view. It discovered what? Dust. Near the sun. We saw all the dust right. But the more close to the sun, the dust was gone. Why? Because sunlight is too bright. It's all melted layer by layer. All melted layer by layer. This is the first one. Then we look at the second followed. Switch back. Notice it playing out corona. Some of the important things related. How about it? You can see it fight back. You see things hurt, playing out the light. It came back to see no. It is not linear folded back. It will switch back folded back. Of course, turning back to its own little loss. Do you see it? Came back and did not go back to see. This is the second feature. The third is the turbulence. CME playing out of time. A large number of turbulence hit the top. Do you see it? The more energy behind the smaller right. It came down the right but not the. It is more behind the April 2019 number 6. Are not seen straight away. Says it gone so far. It's also such a strong energy. CME continues to constantly spray out. So I just say 2000. A considerable amount of that. It CME spray once. The atomic bomb is so much energy. The fourth breaking point is the critical point. What does the critical point? That is your whole coronal mass ejection. Corona's time for it to break out. It naturally form a large number of particles. The formation of the solar wind. See no exit to the outside. Shout out to C. Coronal mass ejection. You see the group from group right. After the spray to it. Spray to which track? Which gets it right? Which gets it right? A group from a group. A group from a group. But this thing is a group from a group, which itself produces this change in energy. Scientists have quantitative data. Non-conventional. The fifth. Small particle events. It is found that there are a lot. Many small particle. This small particle, in the past we did not find. A group CME hit out. After the break out of it, there are many other. Look up hitting Earth. You see a pop group. You see this coronal mass ejection. 2000. Directly over. Even if the hit. Of course, good to see you did not hit the limit. That does particle. This spaceship Parker. Begin to collect the particles. You do not see. You see playing out not to see. The right to break out will not affect it in space. How much does it amount? Will not directly affect it. This all must calculate. This is an important achievement Parker 5. 5 important achievements. To tell you the inside. Why take Parker? Professor Parker who is still alive. They also visited him when the time of launch. Because Parker professor in the study of the sun. Arguably one of the earliest to study the sun. Early also scoff at people too. He went to oldest decades. He is an expert. Then we can look at this. Is the use of the mass to see. Corona went out to play, because the sun is too bright a common thing. Too bright ball of light. You cannot see. See anything, but through this. Not only see the ball of light to see the chromosphere, you can also see a change of CME. Today, use this spacecraft's Parker. Make a conclusion. Tell you. The sun harmful for our benefit. Certainly harm than benefit. How to make it in this enlarged inside Lee. It minimizes the damage as much as possible. This is the world expects goals. Thank you for watching. See you later.